Okay, so in the last lesson, we began our discussion of special triangles, and we learned about our 45, 45, 90 triangles that always occur in this ratio, right? So our two legs are the same, and then the third leg, the hypotenuse rather, is square root of 2 times the length of the legs. Okay. As you can see from our first problem down here, in this lesson we're looking at 30, 60, 90 triangles. So 30, 60, 90 triangles, we can draw the similar model here. Notice they're not all, they don't have legs that are the same length anymore, right? Which makes sense. These occur in a particular pattern. It's a little bit harder to remember because you have to keep the sides straight, right? So there's 3 different numbers instead of just 2 this time. So make sure your notes look exactly like mine here. So 60 is going to be our bigger angle. 30 is going to be our skinnier angle. And then our right angle is going to be 90 degrees, obviously. The shortest side, we're going to label X, just like we did over here. The medium side is going to be X square root 3. The longest side is going to be 2X. Okay, so make sure you have this model in your notes exactly like this, otherwise you're going to have a really tough time with the problems. So this is a 30, 60, 90 triangle. And this is a 45, 45, 90 triangle. Okay, so these are special triangles in that these angles come up often in real life. So you often, like, say you're doing carpentry, you might use 45 degree and 30 degree and 60 degree angles, and then obviously 90 degree angles are everywhere. But they're special also in that, like, when we're evaluating trig functions, which is what we're going towards. So my example of like f of x equals sine x cosine x, we'll do tangent x this time. When I have these memorized, I can use these to figure out points on this function. Okay. So let's look at some problems here. So the goal here is like learn how to solve triangles, but also to start to memorize how these triangles look. Okay. So find the length of side x. They look just like the last example. I'm going to set up an equation now. And what I'm going to do is I'm going to notice that this is the long side that corresponds with x square root 3. So I'm going to say x square root 3 is equal to square root of 8. Okay, so there's my equation, and I'm going to solve that. My solution is going to look a lot like they did in the last problem, right? So I'm going to divide both sides by root 3 in this case. And then I need to rationalize. So I'm going to do times root 3 and root 3. And when two numbers are both inside the root, I can just multiply them. So I get square root 24 over 3. And this is kind of annoying because now I have to simplify this as well. So I will do that over here. What we get, right, is we can do 3 times 8, 2 times 4, and 2 times 2. So we have 2 times 2 times 2 times 3 from the bottom of my tree there. So what I get is 2, and then square root of 6 is left over. So that is equal to the square root of 24. And that is my final answer. So that is the length of that side. Okay, and we could solve a similar problem, or we could actually just like make one move with x to find the hypotenuse, and we'll do that in the next one. And then just to recap the steps, so you can make yourself clear notes here. Step 1 was set up an equation. Then obviously we solve the equation. Then we rationalize. I did leave myself enough room here. because we don't want the root in the denominator. And then we simplify. That's what we're doing over here. And then our final solution was that. Okay. So make sure you capture this example in your notes before moving on, including all the rationalizing and simplifying and all that. We're going to look at two more now, both where you have to find the hypotenuse, so our x is the long side here. Okay. This one is the easier version, so I'm going to draw my model again. My model is x, 2x, x root 3 on the bottom. And notice I have my x, I'm looking for 2x. So this is like very obviously going to be 4, right? Because it's twice as big as the short side. What I could do is I could use the same steps as I used before. I could set up an equation. I could say x equals 2. That's my equation. And that's it. I can't solve that, right? Because it corresponds with x. So I set those two sides equal to each other. Then what I'm doing is I'm plugging 2 in to find the hypotenuse. Okay, that's going to be important in the next one, which is going to be a little bit more challenging than this. Okay, so here's our last example, and this is the hardest way you can be given this type of problem. Okay, so I'm going to still use the same model. Notice what I've changed since the last one is in the last one I gave you the short side. Here I gave you the longer leg and I asked you to find the hypotenuse. Okay, so my equation, in our last one we used 2 and x. My equation is going to be root 2 x is equal to x root 3. So I'm going to set those two things equal to each other. And then I'm going to solve. Right, so the solution here would look like square root of 2 over square root of 3. And then if this were my final answer, I would rationalize, right, and simplify to make it look nice. But we're not done in this case. So like the most common way to mess this up is to be like, okay, here's my solution and I'm done. This x is the shortest side. We need to find the long side. So if we're going by this pattern, we don't want to find x, we want to find 2x. So 2x is our longer side. 2x would be 2 times what we just got. Okay. So that is our hypotenuse. And what we want to do now, here's our final answer. This is what we want to do, or we want to simplify and rationalize. So I'm going to multiply times square root 3 over square root 3. And what I get is 2. 2 times 3 is root 6, and that cannot be simplified, right? Because it just factors to 2 and 3 again. And then on the bottom, I get plain old 3. So this is my hypotenuse. So sometimes, particularly when finding the hypotenuse, you need to solve for that short side and then plug it back in.